next session.
Next
So
session.
we have our next speaker present here, and our session chair is Diganta Sengupta, and we are really proud to have Prasenjit Bhadra, and we have kindly agreed to come to this conference and in a very short time. Thanks to you, sir. And he's really doing a lot of work in the field of industrial IoT, and he has his own company in US, New York. I think he will explain it in detail with you. So for this, may I invite the session chair, Diganta Sengupta, who is also Associate Professor of Meghnad Institute of Technology of Computer Science Department. Over to you, Diganta.
No, thank you, sir.
Thank you.
Am I audible?
Yes, Diganta. Yeah.
Good afternoon, everyone. In this session, we are having Mr. Prasenjit Bhadra as our keynote. So, Mr. Prasenjit Bhadra is the founder and CEO of Ranial System Incorporation, a New York-based startup focusing on industrial IoT platforms to drive robotic process automation, sustainability, cybersecurity, and smart city surveillance. In the last 2 decades, he has served leadership positions in global technological corporations to drive emerging technology innovations and thought leadership. His inventions and scholarly contributions are focused on high-performance computing, industrial IoT platform architecture, enabling cognitive AI. His main research interest is introducing and advancing cognitive AI and machine learning-based process automation that advances clean tech innovation, industrial assessment management, remote patient monitoring, and protect distributed infrastructure from environmental hazards and cybersecurity threats. Mr. Prasenjit owns global patents, research publications, and thought leadership articles in the large-scale distributed architecture of industrial IoT and AI solutions. He is a reviewer and member of editorial boards of international journals like IETE, JMIR, JMSCM, accessing the quality of research and innovation in the field of IoT and AI and distributed systems. Prasenjit is also engaged with global leadership organizations like Top Tier Talent and Society for Risk Analysis, SRA.org, to drive industry academic alliance, community enrichment, and mentorship programs on sustainability, climate change, clean tech infrastructure, and technology incubation in the modern society. He is a senior member at IEEE and member at large at Sigma Xi. He is also a bona fide fellow of British Computer Society and Institute of Engineering and Technology, IET. Some of the innovative engagements led by Prasenjit found place in success citations of smart automation and digital transformation initiatives across the globe. Prasenjit Bhadra has been awarded as CTO, Chief Technical Officer of the Year by Corp America, New York, and Best CEO Leading Business Transformation by TMT News, UK, United Kingdom. He has received MS in Analytics, MBA in Systems, and BS in Electronics. Having said so, I would request Mr. Prasenjit Bhadra to kindly take the stage.
Thank you, Diganta, and good morning, good afternoon, good evening. Am I audible?
Yes, you are.
Okay. Based on wherever you are, it's indeed a pretty long introduction. But having said that, this gives me an immense pleasure to be part of this conference, even though it's the last minute. And looking at the agenda of the conference, I thought I will bring in some of the cutting edge innovation areas where we have been focusing on. In fact, we are driving our efforts to bring the quality of innovation to the 21st century digital transformation. So I have a presentation with me. I will go over that briefly, and I wish I would have had this in person and would have made it more interactive. However, considering the nature of the session, I would like to go over the presentations and I'd like to take any question you might have as I finish my presentation in next 30 to 45 minutes. Are you able to see my screen?
Yes. Thank you.
Yes.
Okay, so we are going to talk about, I think when we look at industry and technology, 2 terms are becoming very popular in today's landscape. One is an artificial intelligence and data science, I believe everyone is kind of doing something or the other in that space. And then the other aspect of it is an Internet of Things, which is a very broad area. So I'd like to narrow it down, see that, sometimes these technologies are very interesting and they're bringing their own value propositions to disrupt the research, innovation, and the society, right? So, but having said that, how do we basically converge these technologies? I mean, in isolation, they might bring in a great value, but then sometimes when you converge these technologies, then they would basically create more powerful construct in the industry and academic research, right? So to start with, I would like to, bring some kind of perspective in terms of what we have really seen as innovation in the industry. Now, if we start with, 18th century, this is where our core technologies in this area of electricity, mechanical, engineering, and to some extent, very mild, I would say, electronics type of an industry started shaping up, right? We had a steam engine, we had, industrial revolution, first industrial revolution, wherein we started building, cars and bring in certain automations that could change the world, right? As we move toward 19th century, we have seen electricity gain significant tractions, the diodes, and followed by transistors, and electronics really dominated the market, right? So, and then as such technologies kind of bought into the mainstream industry as well as society, we have also seen this mass production of the products, gain significant momentum in the industry. And that had been some of the critical growth dimensions towards the Western countries such as US, UK, and Germany, and so on and so forth. But then as we move towards 20th century, towards the end of 20th century, we started witnessing very interesting, developments in the area of information technology and electronics, right? So automation became mainstream. Many of you working in the artificial intelligence and data science, those statistical, models and mathematical formulations became sort of a mainstream interest in the research, right? We also, towards the end of 19th century, we have also witnessed a very interesting developments in the area of distributed computing and networks, right? And this is the time when we actually embarked our journey in the industry, learned technologies, and my personal involvement was more on distributed computing, as well as wireless sensor network integration in the industry. We started working on technologies which are fresh out of the labs, and there are not many references that we had. Unlike, we didn't have a GitHub, we didn't have a Google to browse and figure out what can be done. So it was very exciting as well as very tedious work for us to get those technologies work across the industries and come up with some successful implementations, right? Now, as this is where we are kind of transitioning from the 20th century to the 21st century, and we started looking at a pure a pure digital inclusion into the mainstream industry and automation. So the democratization of information technology and computer science started its journey very slowly in the late 20th century, but it became a sort of a mass adoption, I would say. We have witnessed a mass adoption in the beginning of 21st century. We have been looking at, or we have been working actively bringing in the smart systems. And I was at IBM, we are working with the Smart Planet initiatives. And then we have been basically trying to converge, sensors and actuators, RFID sort of technologies to bring in an operating technologies. So now what we have really devised or developed in mostly in 18th century and 19th century with the information technology that we bought in 20th century and of course beginning of the 21st century, we started basically trying to look at a convergence and how these two technologies could work together to change the way we do business, the way we live our life on a day-to-day basis. And at the towards of last decade, as we have seen a significant developments in the area of cellular network and the smartphone. Now we know what we really live in the world we live in right now. It's very difficult to live without the data at any given point of time. So at this point of time, the world that we live in, wherein the exchange of the data, the collaboration across systems, across human and the machines have become very critical, because now data is sort of a fuel for our daily life. Now, having said that, as we figured out the way we can exchange data faster, with the evolution of big data, we have learned how we could store a massive amount of data and process data. Now, again, that shuttle developments of artificial intelligence gain significant momentum. Now we are able to run certain models and certain algorithms much faster with massive amount of data, and thereby gain certain actionable insights over time. So this is a kind of a journey that I always love to talk about, because we can always connect dots where we are today with respect to some of the developments happen over a couple of centuries. So now, as we have gone through the journey of industrial automation, bringing in mainstream data processing and information technology within the organization, we have also faced significant challenges in some cases in the firm, right? So we have seen that certain technologies the investment on certain technologies happen heavily at a point it is very difficult to get rid of, right? Because so much investment been made, it is very difficult to ripple and replace those with the newer technologies. Now, we have also seen a major attacks from those hackers and intrusions are kind of really disrupting the business. The business became more and more dependent on information technology, and they are highly distributed. All the sites are connected. And if some of you guys are following news, we have seen that Russian hackers literally blocked the gas pipelines of US, charging millions of dollars to basically have those infrastructure operational again, right? Now, at the same time, these industrial foundations have been operating, and whether it's a CNC or PLC machines and the sensors, the SCADA systems, and if you guys are familiar with these names, they're generating a massive amount of data. And in the industry, unfortunately, for last 20 to 30 years, we have been collecting so much data, but then we are hardly using any data. We are literally collecting the data and purging the data. Only a fraction of the data in its historical significance being utilized for some due diligence purposes. Or if there is any predefined rules available, they are basically processing this data to create certain alarms. And a majority portion, maybe 80% of the data is kind of misutilized or unutilized in a current landscape, or at least the world that we lived until, I would say, 2010, 2015 timeframe, right? Now, every other automation we bought in, and as the demand grew, as the industry grew, we have seen a very challenging ambience in terms of scaling our infrastructure and solution up to meet the growing demand. Okay, one, the downtimes, right? Industry has embraced certain amount of automations, then they cannot just go manual if there is any technical fault or a technical issue. Okay, now as we also have seen, all of these plants, I mean, I'm just providing an US data, but this is true for all developed countries, right? All these automations that they have bought in, now they realize some of the pains, but as I already mentioned, that it is very difficult to basically replace those older technologies with a new one. I mean, not if you talk about India, but then India or developing countries, if you go back to US or any other developed countries, you have infrastructure. Those are as old as, like 80s or 90s, they're still operating. And there are some incremental changes being made, but it is very difficult to literally transform those with advanced technologies and automations, right? And now this has become a de facto need for industries to bring in more and more investments, because the consumers, the end users are becoming more and more digital. And now it is become a very important journey for the industries, or they are at a juncture wherein they have to invest more and more money in terms of digitizing their existing environment. However, they're not able to scale that up by virtue of the limitations they are living with at this point of time. So we talked about an innovation. In these slides, we talked about some of the current challenges that we are dealing with. And now we realize that if we have to live up to the expectation of the industry, then Internet of Things is something which should definitely help us to connect the dots, would help us to mitigate the risks, would help us to close the gaps between our current state and the target state infrastructure. So how is it different than the standard automation? So automations, those are built by some of the leading organizations such as Siemens, ABB, GE. They have been building something which are very ground up, very fundamental, closely connected, closely coupled.
Hello.
Sorry.
Hello.
Yeah. So
there was some. You please carry on.
So they're closely coupled with the enterprise systems, right? But then we have to figure out something that could potentially
Hello, Debashis.
the state of existing automation, which is not able to scale up and provide that extensibility and scalability with the future state digital foundation. So Internet thing is basically, in my opinion, is a glue between these two, right? And eventually this Internet of Things will become the mainstream operating technology foundations, which is already underway, but it is going to take some time. But we are living in an era for next 10 years, wherein Internet of Things is basically provide a sort of a cushion where the next generation digital transformation could reside. Now, what is really an Internet of Things? I mean, the slide clearly depicts some of the key aspects of Internet of Things. Okay, so there are a bunch of sensors that we are dealing with, and the sensors are collecting data. Now, these sensors collecting data, this data is basically riding over the networks. Now, if you could have networks, those are wireless networks, wherein one or more sensors kind of collaborate with each other to produce certain types of events. At the same time, you could have sensors simply pushing the data and this data going back to the cloud. And now cloud is capturing the data. and cloud is processing the data and creating certain insights. It could be prescriptive insights, predictive insights, and creating alarms and notifications, right? So this is a by and large an architectural pattern wherein you are bringing in multiple technologies at a different levels and creating a seamless runtime that could potentially deliver certain unique intelligence and process flows, I would say, operational flows, to embrace new aspects of the contemporary aspects of digital usage, right? So, and we have been witnessing that pretty significantly. We have been using voice to text, voice over technologies. We have been also using our smartphones to a large extent. The home automation is also in its way in India, but that is significantly gained significant momentum back in US. We'll be talking about electric vehicles. We are talking about integration of distributed energy resources, which are some of the sweet spots that we are working in. And so it's the opportunity and scope of implementing Internet of Things across multiple industries are endless, right? And we keep on hearing new and interesting opportunities every now and then, and we see, okay, how do we fit Internet into it, Internet of Things into it, so IoT into it, right? So the machine to machine and Internet of Things is basically not only bringing new possibilities to meet the market demand, but also very interesting research opportunities in some of the technology initiatives or areas depicted on the left hand side, right? So now all of these we are working on, all the aspects of, again, if we go back to our first slide and we talked about some of the key challenges. So everything revolves around the data. We are talking about, I have mentioned 50 billion devices, which is kind of slowed down in 2020, but then if everything goes well, analyst predicts we'll be connecting 75 billion devices across the world, interacting with each other and producing massive amount of data. So the value that we are trying to create out of some of these, interesting machine to machine and Internet of Things type of integration, which is probably the most significant development in the 21st century, is also revolving around the data. So we cannot isolate a sensor integration, wireless networks from not having artificial intelligence kind of bringing in the value proposition in terms of extracting the meaningful insights out of it. And this is where the convergence come into the picture. Many of you are studying into and maybe publishing your papers. You'll be conducting your research. So this is becoming very critical to the mainstream developments in all sorts of automation, be it electronics or computer science. How do we basically bring in that type of or adhere to convergence of certain technologies? It could be AI with wireless networks, or AI with some embedded systems. Or if you are working in VLSI, how could we embed AI into the VLSI? So this is becoming a very critical, or very important area of contributions in the next generation research as we speak. So now I will bring in another aspect of this technology, and then we'll talk something about security as well, which we touched upon briefly. So, those who have, worked in the last century or might have come across some of the implementations such as RFID sensors and actuators, you have seen that today's IoT system is something I call as old wine in a new bottle, right? That means we have been doing the same thing, right? We have been collecting the data from RFID systems, which are able to ingest a massive amount of data, even though it's an RFID identifications, but then we also integrate some of the sensors. So we will do a first level of filtering at the edge of the network and then move the data in the server, and server will basically process the data, and dashboards will render the data in different meaningful charts and graphs. Sometimes it could be embedded on Google Maps. If you're talking about a mobility solution, will also deliver certain analytics, BI. It's not like artificial intelligence. It's a BI type of implementations. But then there are two things we could not embrace. And even though those days my publications were were not that digital, but some of you have read, we have been witnessing another interesting challenge that unlike 3G, 4G generation, and most of you lived in the second generation network, when we have a distributed automation of operation, we were not able to really create a reliable system over a cellular network, right? Or to some extent, even if we use something called Zigbee, which is I think predecessor of XB protocols, we didn't have many wireless protocols which are very robust enough. They are more local in nature. So in a broad distributed systems, we are not able to do that. And if you have enterprise network somehow, running those wires from the place where you're collecting data to your data center, you are better off dealing with such kind of systems. But having said that, that kind of bothered me, and my research was, hey, there is no way we could just dump everything in the cloud, or those days cloud was not a term. Those days, IoT was a term, but then not widely used. I think IoT was not used, a term was not used before, even before 2012, 2013. So among all the publications we had, or I had at least two of those are talking about the edge computing in that data. We talked about edge controllers. We said that, we have to decentralize this. And this has become a mainstream, driver of some of the leading technology developments in the last 5 years, right? So of course, we talked about it much ahead of time. And this is a realization at that time. But now the situation, the context is a bit different. The difference is, those days we are trying to avoid limitations. So we said that we just cannot dump, terabytes of data into the server. No one can handle that data. So we have to do certain filtration, aggregations, and then send a clean data back into the cloud and then process it. And if it is not able to handle it, just purge it. Our first implementation with big data went live in state of New Jersey, where we built world's largest distributed solar operations. That's where we first utilized big data in an IoT ecosystem. That was our implementation. I was a chief architect for that, but then having said that, I didn't know at that point of time, big data was also used in the typical machine-to-machine and IoT. So I would say that this is one of the first generation implementation of the big data. But having said that, by then we have kind of recovered from the issues that we were facing, one, latency, bandwidth, to some extent, right? In terms of managing distributed automation. And so even though we talked about edge computing, but the network was much more reliable than 2G or first generation data network that we have dealt with. So that crisis, gave birth of edge computing, and it became critical because we became hungry. We became more hungry to embrace more sensors, more data, and more implementations. So now, even though we grew to an extent from 2G to LTE, now we are talking about 5G, which is going to be bringing massive speed. And we have witnessed the difference of 5G from 4G, and those who are in India will probably also get the flavor, wherein like anywhere you're traveling, you'd be able to watch videos, your video calls, you will have a kind of a seamless experience. But even after that, the massive amount of data, one, we are able to produce, two, we are able to store, three, we are able to process. We just cannot rely on a remote, a distant cloud kind of capturing this data and processing the data. And that gave birth of edge computing, right? But then what are the key elements, that we could look at when it comes to edge computing? So we cannot deny the fact that edge computing is the next, is the future of IoT. And edge computing is not IoT. I'll talk about that. But edge computing is an integral part, or I would say it is going to become the entire circulation system, I would say, the herd and circulation system of IoT in next 5 to 10 years, right? Now, each of these elements that we are showing here could be one research area, okay? But then I would not have time to go over all of these in great detail, but I'll be more than happy to take any question if you have any specific interest. So with this approach that we are bringing in, we are also creating another hole within the system, which is basically we are bringing the computation from the highly protected firewall data center to the physical environment. So we are allowing these hackers and the intruders basically, inject malware, ransomware, sending bad requests to get an access and then hack the network and so on and so forth. So security becomes a very critical challenge as we speak, right? So having said that, the important part is trying to come up with certain technologies and tool sets to protect this infrastructure. Okay, so since this conference is also geared towards the security, so now what we have envisioned, one, we talked about a massive amount of data we are processing and storing. So edge computing is providing us a way to capture the data. It is also able to bring in the real-time intelligence at the edge of the network. So you can now run models within the edge computers, right? So that means, okay, fine, now you have AI, you can talk about tiny MLs. So you are talking about bringing in intelligence at the edge of the network, which will process and actually take what we call as a situational awareness, right? But then this is also creating a very interesting opportunity of research and development, wherein the AI will be able to understand the anomalous pattern of certain requests made or certain injection made into such type of edge computers, and thereby protect the entire network, the entire infrastructure at the point of action itself. So AI and certain models that you could build that can run within a smaller footprint of these devices can literally capture some of these anomalous activities and any of the cybersecurity threats, right? So, when we talk about edge computing, there are different areas and focuses. We have fog computing, and we have mobile edge computing, and then we have what we call as a cloudlets. As I said, that the edge computing that we are talking about here is more geared towards a fog computing constructs, wherein your edge controllers, network equipments, and they're talking to the sensors, processing the data, connected over various types of networks back into the cloud. But this fog computing infrastructure is not heavily dependent on cloud infrastructure. Mobile edge computing networks is basically providing similar features of fog computing. However, this is more to deal with network and network level operations, and this is only connected via the LTE or 3G or 5G backwards, right? Fog computing can have multiple hops, but MEC is basically one gateway that moves the data back into the cloud. And cloudlets is basically what we call as a virtualization of cloud, because a lot of operations that you want to run in the cloud would have certain latency issues. But then if you are able to create sort of a proxy of this cloud close to your enterprise, you can run certain operations and that can synchronize back to the cloud. So this is the overall perspective of edge computing. But then, fog computing is something which is becoming more and more relevant to the IoT. Having said that, we are right now working with IBM. They are our partners. They came up with a technology where in this IBM cloud, they have what they call as IBM, satellites, which is a cloud proxy. But then how can we basically combine fog computing with these cloudlets to create an incremental value? So more real-time fog computing, near real-time on the cloudlets, and something which is batch, very process intensive operations require a lot of training, can be done in the cloud, right? So traditionally, all this AI stuff that we are trying to do, I'll try to wrap it up real quick. Most of the cases, you basically run certain models. Build those models would require GPUs and large amount of RAMs, and that becomes a very critical challenge for you to have something real time. And one thing that had happened in the last 15 years, I would say, that whenever we dealt with the data, we always dealt with the historical data. One, okay, there is nothing wrong learning from the history, but then this is not able to really embrace the dynamics of the environment, right? At any given point of time, things are changing all the time. So we have to have analytics that can embrace the patterns and understand the issues more real time. So you could have an enterprise computing layer training the models. You have the models, have them deployed in a microcontroller or microprocessor based units, and they can run it. They can still do a better job than having static logics and rules. However, the interesting challenge is they cannot adapt or learn over a period of time. So that is where the cognitive intelligence come into the picture, right? So these are all soft computing based models. I would skip the slide. So you basically be able to get some ideas, and I'm actually the chair of North Jersey Computer Intelligence Society. I mean, this group in IEEE focusing on soft computing, fuzzy-based model, neural networks. So a tremendous amount of research is going on right now to, we have achieved with deep learning, we have achieved almost 98% accuracy. But the throughput it requires in terms of getting those models trained and then deliver the value propositions in terms of object detections is mind-boggling, right? However, we are trying to figure out how we could increase the speed of this learning or learn on the go and thereby produce an interesting outcome, right? It might not be as accurate as what a typical deep learning model or a neural net CNN type of model to do. However, that could bring in a significant value proposition in terms of running it into a smaller footprint or in a system on chip, right? So I would like you guys to look at some of these developments in the computational intelligence society. And if you guys would like to be actively involved with the society and do some work, feel free to reach out to us. We can help you in this regard, right? So I will skip through. So some of these implementations that we are talking about, we are talking about a massive scale of distributed energy generation. We are talking about a smart city. And in a real sense, when we are connecting so many equipment, there's no way you can have a city sending data in a cloud server, you're processing and bringing that. They all have to collaborate with each other. And that is where the power of edge computing with the cognitive intelligence will come into the picture. But also this AI that you're building would play a very critical role in terms of protecting these infrastructures and assets. Otherwise, we might land up in a situation, we have an excellent automation, but it is prone to cybersecurity threats all the time. Right, we are also working with another interesting project wherein we are having storage on the wheel. So you have large scale energy storage that can kind of light the entire city, like 12, 13 megawatts worth of power stations moving on the wheel and kind of providing a need-based power. Having said that, this is also very prone to risk. And you are thinking like this is just a battery storage that is moved from one place to another. No, this is connecting to the grid. It has to balance the power. It has to avoid any catastrophic failure or technical losses and so on and so forth. So we have to literally move a substation along with it. So now, without having IoT with edge computing and cognitive AI, we could never achieve such type of excellence in our modern time. So all of these systems that we are talking about, usually get two variants of it. We cannot say that we just cannot have a system which will not have a cloud. So obviously your dashboard visualizations, alerts that you're sending through SMS and so on and so forth. So all of these features are kind of a cloud construct. So you'll have cloud construct, but it will be very limited. So it could be either on premise or hosted. So these are the two variants, and then a lot of research and work going on in terms of designing clouds that could be compliant with edge computing and cognitive AI. So with that said, I'll just pause here and would like to get any questions that you might have that I'll be more than happy to answer. I'm not sure if I have taken a lot of time for you guys, but then I just wanted to quickly wrap up and see if there is anything that I can answer.
It was a very, very informative session, and I hope the participants have all gained enough insight into what is happening and what is the deployment part of the blockchain, cybersecurity, network, AI, all the happening technologies that is happening right now in the world. So now we can take a few questions, one or two questions. If anyone has any question regarding whatever we have seen just now in the slide to Mr. Bhadra. So anyone wants to ask any question or anything? Okay, fine. So I hope everyone has got the essence of whatever you have presented, Mr. Bhadra, and the picture was very clear of what is happening in the industry and how you have presented it. So with this, I will thank you a lot for your delivery and hope to collaborate with you in future. So having saying so, we will move forward in this session.